We're going to look at Lesson 7, Unit Rate as the Constant of Proportionality. So we're starting with an example about the National Forest deer population. And this is a real-world situation. Here's a question. Why does it matter if the deer population is not constant in certain areas of the National Forest? So we have a situation where we are told scientists were doing some studies and they found there were 144 deer in 16 square mile area of the forest, and in another part 117 deer in 13 square miles. Let's see, 144 and 16, and then a third area there were 216 deer and a 24 square mile plot of forest. So, first of all, why does it matter? Well, I pulled up some clips to visualize why it matters. So if we think about food webs and how population is important for that, you've got the deer here, and if there's not enough deer, then maybe the forest is going to be overgrown. If there's too many deer, maybe we're going to have some car wrecks with deer. Or looking back at the food web, if there's too many deer, maybe there too many mountain lions. There wouldn't be enough mountain lions to feed the deer. So lots of different things scientifically could be impacted if the deer population was not consistent. Which leads us to the question, is the deer population consistent? So we have the number of deer divided by the square miles, and let's see if it is consistent before we get too worried here. Clear that off. So 144 divided by 16, there are 9 deer per square mile for the first area. For the second area, there are 9 deer per square mile. So maybe we have nothing to worry about after all. In the third area, there's also 9 deer per square mile. So the unit rate of deer per square mile is 9. The constant of proportionality is 9. The meaning of the constant of proportionality in this problem, the 9 is 9 deer per square mile. Use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. So, going back up here, we do y divided by x. Okay, so the number of deer equals 9 per square mile. Okay, and I'm going to go ahead and label that. I'd like for you to do the same. The number of deer, and then this is square miles, and this is our 9 deer per square mile. Okay, so what am I trying to do? 207 square miles. So that was my x value. So I'm going to use my equation, 9 times, instead of x, because that's square miles, I'm going to put 207. So y, or the number of deer, is 1,863 deer in 207 square miles. I should probably go ahead and write it with the label. Okay. Use the unit rate to determine the number of square miles in which you would find 483 deer. So this time, starting with my equation, I have the number of deer, which is my y value. So 486 equals 9x. To solve this equation, I would divide each side by 9. This is 1. X, or the number of square miles, would be 54. And I would write 54 miles square miles. So that was kind of fun to think about. I know some of you are probably deer hunters. I'm not a hunter, but my husband is, so I'm going to pause this and show you a little picture of his big buck this year. He sure was proud of all these horns it had. So just thought I'd share. Now on the next page, we have some vocabulary in this little box, and then we've got our equation, y equals kx. So k is going to be the constant of proportionality. Constant of proportionality. Also known as the unit rate. So there's that. And then we have another example. This one's about Brandon. Oh, Brandon's going to be in trouble here because he came home from school and informed his mother he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Well, this school's about 1/3 of the size of ours because we have about 300 students in 7th grade. But anyway, if I was this kid's mama, I'd be pretty upset that he volunteered without checking. Unfortunately, he needs the cookies the very next day. Oh my goodness. Brandon and his mother determined they can fit 36 cookies on 2 cookie sheets. Now, is the number of cookies proportional to the number of cookie sheets used? Number of cookie sheets. Okay, so 2 cookie sheets can fit 36 cookies. So 1 cookie sheet would do, let's see, 36 divided by 2 would do 18 cookies. All right. Well, I need 96 cookies. Oh, I think that's going to be maybe about 4. So it looks like this is my unit rate, that I can fit 18 cookies on 1 cookie sheet. Okay, so then if I did 4 times 18, 72, still not enough. Maybe 6? 6 times 18? That's too many. So maybe it's 5. 5 times 18 is 90. I ran out of room. I'll just write it over here. Okay, 36 divided by 2 is 18. Okay, so the unit rate of y to x is 18. The constant of proportionality is 18. Okay, in context of the problem, that's just what we did there. 18 cookies per cookie sheet. Now, if you're not a baker and you don't know what a cookie sheet is, let me pull one up for you. It's just a pan. Just a pan. Cookie sheet's a pan. It's like a thin pan. In case you didn't know. Now, the next question says it takes 2 hours to bake 8 sheets of cookies. Brandon and his mother begin baking at 4. When will they finish? So that's a pretty big question that, first of all, I'm going to have to do some more math to figure out. Now, if I look closely, he needs 3 cookies for each of the 96 students. So let's see how many cookies he needs altogether. 96 times 3. 96 times 3 is 288 cookies that he needs. The light was right there. Okay, so I get 18 cookies on 1 sheet. So I'm going to divide that by 18. 16 cookie sheets is what I need. 16 cookie sheets makes 288 cookies. Now, let's go back down here now that we know this. 2 hours to bake 8 cookie sheets. But I need 16 cookie sheets. So that means I'm going to need, let's see, that's doubled, so I need to double this. I'm going to need 4 hours. So if I need 4 hours and I'm starting at 4 o'clock, when will they be done? 1 hour, 2 hours, 3 hours, 4 hours. It's going to be 8 o'clock p.m. before these cookies are done. And that's just the baking part. So, little buddy Brandon is in trouble there. Moving on to our next question. I liked that question. I can see a kid doing that to their mother. Maybe not this year. I want to share baked goods this year. Okay, Suzette and Margot went to prepare crepes for all of the students in their French class. A recipe makes 20 crepes with a certain amount of flour, eggs, and milk. The girls already know they have plenty of flour to make 50 crepes, but they need to determine how many eggs they need for the recipe because they're not sure they have enough. Okay, so let's see what we know. We know 20 crepes, 2 eggs. So if I know that 20 crepes, 2 eggs, let's see, 1 egg makes, see, that would be divide by 2. So if I divide this by 2, it's going to be 10 crepes for 1 egg. Now, what is a crepe? I love crepes from it's like a really thin pancake. All different kinds. They are definitely yummy. Really thin, kind of folded up pancake. Okay, back to the math. All right. What is the constant of proportionality? So we just figured out that I get 10 crepes per 1 egg. There's my constant of proportionality. There we go. How many eggs for 50 crepes? Well, if it takes 10 crepes from 1 egg, then 50 crepes is times 5. So that would be times 5. And I would need 5 eggs. Final answer.